Hello, and welcome to the screencast in which I, Scott Balicki, will talk about the Alchemy unit, the first unit in Living by Chemistry, the curriculum supported by Boston Public Schools Science. So, in this screencast, I'm going to give you an overview of the Alchemy unit. I'm going to discuss 3 difficult lessons in detail, and then provide you with some additional resources. So the Alchemy unit is divided up into 5 sections. The first section is the first 5 lessons, and it's about defining matter. The second lesson, 6 through 10, the second set of lessons, are about basic building materials. In section 3, we begin to discuss particles. So we're talking about like protons, neutrons, etc. in the atom, and those are lessons 11 through 16. Electrons are focused on in section 4, lessons 17 through 24. And then we go to section 5, where we talk about building with matter, start talking about some macro, micro properties. So in order to give you a little bit more detail here, I am going to go through a quick summary of each lesson, and I'm just using the online version of the textbook, which you should have at your school. So lesson 1, tools of the trade. That's an interesting way to start the year, also in a safe way, where students carry out a scavenger hunt involving laboratory equipment. In lesson 2, the teacher performs a demo in which they make a seemingly gold penny by performing a series of chemical reactions. And this sets up students to investigate, like, what kind of evidence can they accumulate to prove that the penny is or is not actually gold. In lesson 3, it's called What's the Matter? And it's all about coming to a consensus as a class about how we define what is and what is not matter. Lesson 4, students take some measurements of mass and volume of devices. In lesson 5, they learn about intrinsic properties of substances as defined by those substances' density. Moving on to section 2, lesson 6 is where students are introduced to a new language, the language of chemistry, in which they learn about chemical names and symbols using kits which need to be built at your school. So that lesson requires a lot of prep if the kits have not already been built. So that should be on your radar. In lesson 7, this is the copper cycle lab, which takes place over 2 days. This is one of the 3 defined difficult lessons. So I'll talk about that in more detail. In lesson 8, students analyze the copper cycle lab and kind of like summarize what they've learned. In lesson 9, they create a table using a deck of cards from the kit, which must be purchased from BFW, the website which was discussed in the overview screencast. And then in lesson 10, students make sense of the patterns that they've found in this periodic table that they've constructed. In section 3, we're talking about a world of particles. We talk about models of the atom in lesson 11. In lesson 12, students learn about the difference between atomic number and atomic mass. In lesson 13, students learn that that atoms have different isotopes based upon the number of neutrons they have. Lesson 14 investigates the relative stability of isotopes for atoms. In lesson 15, students learn about what happens when these isotopes undergo transitions through nuclear reactions. The Nuclear Quest board game is part of the Alchemy kit, which I've already discussed the school would need to purchase if you do not have it already. In lesson 16, Old Gold, students look in more detail at nuclear reactions. We then go to section 4, which is talking all about electrons. So we introduce this section by looking at technicolor atoms and the flame tests, one of the 3 difficult lessons, which I'll discuss in more detail. Lesson 18 talks about valence versus core electrons. In lesson 19, students construct a table of ions rather than a table of atoms and start to look for patterns in what kind of ions form in which atoms. In lesson 20, Getting Connected, we learn about the law of zero charge in terms of the ratio of cation to anion in an ionic compound. In lesson 21, students play Salty Eights, a card game which is in the kit from BFW. In lesson 22, a different card game in which students learn about polyatomic ions. Lesson 23 is very time and lab intensive for very little payoff, I have never taught lesson 23. This is the only lesson in alchemy that I tend to not do with my classes. Lesson 24, students learn about the electron configurations of main group elements. We then move to section 5. You Light Up My Life is a very important lesson in which students see macroscopic evidence for the microscopic bonds between atoms in compounds. Lesson 26, students learn more of a model of bonding. And lesson 27 involves electroplating in a very exciting lesson to end the unit. So, to talk in more detail about some of the difficult lessons, the copper cycle must take place over 2 days, and the first reaction that is performed must take place under a fume hood. Not on a windowsill, not outdoors, in a properly maintained fume hood is absolutely essential because it produces toxic chemicals, nitrogen oxides, which students absolutely should not be exposed to. So it cannot be done in an open air lab. It can only be done under a fume hood. I have student groups line up to perform it under the fume hood with the screen down so that they can all see it, but I actually add the nitric acid in order to ensure that there's no risk of students being exposed to that. Other than that, all the other steps are safe to do on benchtop in the lab. And the first day of the lab, the end product is a solid wet compound, which needs to dry overnight. If you have block scheduling and are trying to do the 2 lessons in 1 day, it is possible to then take the wet substance and add it to the next reactant in order to continue carrying it on. But if you have traditional 45-minute periods like I do, the lab takes place over 2 days. In the resources, there is actually a full video of all the stages of the lab. Difficult lesson 2 is Technicolor atoms, and this is a flame test. The only reason I highlighted this is because in the teacher's guide, they recommend giving students every single reactant to put into the flame and see the color. And that provides a lot of opportunity for cross-contamination, thereby making it so that students don't actually observe the correct colors of substances. What I do with my classes is I have single stations at Bunsen burners in which students observe only one substance in the flame test, and then move on from station to station to station. That reduces the opportunity for cross-contamination and ensures that students see the proper flames and come to the correct conclusion that it's the cation rather than the anion that is causing the colored flame. It is also possible to fudge many of the substances with different anions. For example, if you have calcium chloride and it calls for calcium nitrate, you can put the label calcium nitrate on the bottle, and students would not know because the calcium, the bright red color of calcium would still be observed. So if you're concerned about not having every single one of the species, as long as the cation is constant, it will give the same flame test and students will discover what they're supposed to discover. Difficult lesson 3, You Light Up My Life, I would recommend organizing into trays or stations where students don't have every single substance to test, but rather test a few substances at a time and then move on from station to station. So for resources, this is a link for the entire copper cycle on video. If you go to my website, in the second bullet point there are supplemental lessons and animations which may be useful for you during the alchemy unit. And the third bullet point shows the link to the BPS Science Weebly, where there are pacing guides, student learning objectives, and a calendar. Here is contact information for anybody that you may need to contact in order to get support in teaching with Living by Chemistry.